Now, children, listen carefully. In our previous lesson, we had discussed about acceleration and accelerated motion. In acceleration, we had discussed that whenever any object change, or if we find there is a variation in velocity, then we can calculate acceleration of a moving object. And we have a mathematical equation. And what is that? Acceleration is v minus u divided by t. Means change in velocity divided by time is an acceleration. Now for today, we are moving to next topic, and the topic is motions graphs. Listen carefully, students. Motions graphs. Now, children, suppose you are running a racing event, or you have participated in any event in a racing event where motor cars, bikes, there are speed competitions. And children, in that competitions, you can trace the motion of the moving vehicles. What is the speed of the car? What type of motion is there? Whether it is a uniform motion, non-uniform motions. So you can trace. So first thing from the graph that you have to understand, and the first type of graph is distance time graphs. Distance versus time, children. What is actually this distance time graph? It is a graph between time versus distance. So if some object is in motions and you are trying to plot the distance, how the object is changing its position with respect to time. And basically, children, in our curriculum, we have two types of graphs. First one is distance time, and the second one is the speed time graphs. Even though we have other kind of graphs also, acceleration time graph there, force versus time graph there are so many type of graphs, but in this chapter we are going to discuss two kind of graphs: distance time and speed versus time. Now children, have a look on this graph. Have a look on this graph carefully. Observe it. Along the x-axis, we have taken independent variable, that is time. Please remember, we will take independent variable on the x-axis every time. Along the y-axis, children, if you observe, this is the y-axis, and here we have taken dependent variable, that is distance. So how this distance change with respect to time for a different kind of motion of an object. Now children, please remember that the distance is here in meter, 200, starting from 200, and the finally it is 1400, and the time limit is taken 100, 200, 300, and up to 800 seconds. So they have recorded, cognitive have recorded a motion of a object from a time interval of 100 seconds, and then object has covered a distance of 1400. Now children, please observe the graph, how they have plotted a graph. First we have section A, then we have section B, section C, and finally we have section D. And we are going to discuss what is the meaning of this graph A, section B, section C, and section D. And students, these graphs questions are really very, very important questions. In this chapter number 2, in exams, definitely there will be one question based on graph. So it is 100% sure, children, you will get one question on this topic of motion graph. Now let me continue with this topic, children. I hope that you have gone through with this graph carefully, and we will predict what kind of motion is there. Now children, let me begin from the section number A, means line A of this graph, this one. And I want to draw this individually, this graph along this side also, children, that the time is there, and distance I'm taking D here, and this is something like this, the line A for the graph number A, children. Now, children, if you observe, line is straight, and so it means if line is straight, the object has covered equal distance in equal interval of time. So what kind of graph is this, children? If line is straight. So finally, if you see within a time interval of 200 seconds, object has covered a distance of 400 meter. Within a 200 second, it's a mathematics, children, how to plot this graph. Suppose if I say 400 and 200. So how to plot? The 200 will be here along the x-axis, value of time, and the 400, that is the distance, which will be here, and you have to plot the point will be here. Then you will see. Similarly, it's not about just only 400, 200. It's about the many. When the time is 100 seconds, at that time, the distance covered is point will be like here. Then you will join. And similarly, when the time t equal to 0, then the distance was 0. Initially, that object has started from the 0 point. Now, in that situation, what kind of this graph is? Now, let me show you, children. Is there anyone who can predict type of graph this line A? Anyone from 9th class? No. Now, let me explain, children. Now, here, children, that in the first line, you can see the line is sloping upward. Yeah, definitely, it is sloping upward. The bus travels 400 meters in 200 seconds. So it means the bus is traveling at a constant speed. Just underline this part. Bus is moving with a constant speed. And what is that constant speed? 2 meters per second. As I told you, children, that the bus has covered a distance of 400 meters in a time of 200 seconds. Can you find out the speed? Yes, speed is given by, the mathematical equation, children, speed, distance divided by time. Distance is 400 meter, time is 200 seconds. If you do the calculation, you will find speed is 2 meter per second. It means whatever the object is moving, that object is able to cover a distance of 2 meter every second. Every second object is able to trace or cover the same distance of 2 meter. And then I can predict from the motion graph, distance versus time graph, children. You please note down somewhere. If line is straight, sloping upward, children, then this will show object is moving with constant speed. If you have observed this kind of graph, children, that it means object is moving with constant speed. Object is not accelerating. Object is not accelerating, but here object is moving with the constant speed. Every time same distance is covered in a given time. Now the second point, children. Let's discuss about the second line. In the second graph that you can see, children, line is a flat line, horizontal line. Please observe, we are now talking about the B part of the graph, children. And if you observe here, what's happening here during the time interval of 200 to 400 seconds, means in the next 200 seconds. Here, if you see, the distance is not changing. Time is changing, but the distance is same. What is the same distance? This is 400 meters. So what can I conclude from this time interval of 200 to 400 seconds? When the line is horizontal, it's a flat horizontal line, children, in a distance time graph versus, yeah, Yon Kim, any idea? Line is horizontal in a distance time graph. What kind of motion is this?
Or maybe the bus is taking a rest.
Yeah. Here, children, bus is not at all moving. Bus is stationary, means after 200-second bus stop, car stops. Whatever object is moving initially from 0 to 200 seconds, now for the next 200 seconds, because distance is same. Now children, that I told you, distance is not changing, position is not changing. If position is not changing, it means that object is not moving, object is stationary. So whenever you find in a distance time graph, line is like this, horizontal flat line, it shows that object is stationary. Now suppose children, if I say in exams, what kind of question examiner asks? First question that he can ask you, that you have to plot a graph of a school bus, standing in a parking area. A school bus standing in a parking area, or a school bus stationary at outside of your house to pick up you. How will you plot a graph? Remember, condition is that bus is stationary. In that situation, distance time graph, remember, it will be horizontal flat line, depending upon what the time intervals you are taking. I hope this second part is clear. Now let me move to the section number 3 of this graph, part C of this graph. And if you observe, is there any difference between section A and section C, children? Part A of
Section
the
C
graph?
is more steep than section A.
Yes, very good, children. Very good. If you see that there is a small difference, and what is that difference? The difference is that object is moving in the graph A, object is also in motion in graph C, but the difference is that, what is the difference? The line is steeper, slope is higher. We will discuss about the slope in the next in just a few minutes, children. Slope is higher for section number C compared with A. And now children, if you see carefully, the time interval is again 200. How much distance object has covered? Distance object has moved from 400 to 1400. So what is the distance? 1400 minus 400 is that 1000 meter. 1000 meter distance is covered by the object in the same interval of time, that is 200 seconds. Can you find out the speed? As we discussed, children, if there is a slope, if the line is upward, sloping upward, you can find speed, and the speed is given by, what is the speed? Distance upon time taken, 1000 divided by 200. And if you do calculation, so you will find here the speed is 5 meter per second. If you recall, children, we have calculated the speed from a time interval of 0 to 200 seconds. At that time, the speed was 2 meter per second. Now it's speeding up. Steeper means speeding up, children. Here, this section of the graph represents this speeding up. Still, object is moving with the constant speed. But now this time, actually, I'm just comparing C with A. Here, speed is 5 meter per second. Now from C, in section C, from the time interval 400 to 600 seconds, object is able, here children, remember, speeding up means that it's not accelerating, speeding up, I'm using this word, that comparing with the section A, here speed is 5 meter per second, and that remains constant, means every 1 second, children, that car or the moving object is able to cover a distance of 5 meter every second. You children, please note down this graph. And now let me go down here to show you, come to this point number C, children, what they have mentioned here. 4.C, the line is sloping upwards quite steeply. A steep line or higher gradient indicates a faster speed. Now that the car has increased its speed in when car reached to a time interval of 400 seconds, means after 400 till 600, car speed moves from at a speed of 5 meter per second. There is another graph, children. The D graph is also there. And D is again a flat horizontal line. And what do you mean by this flat horizontal line? In a time interval of 600 to 800 seconds, children. Again, position is not changing, distance is not changing. So it means that children, object is stationary. There are just few important points. Please you note down in your notebook, children, that conclusion of this topic. The first point, a straight sloping line in distance time graph, children. Please don't be confused because we have two kind of graphs: distance time, speed time graph. In speed time graph, sloping line means constant speed, as I told you, children. Constant speed. Second, a straight line, sloping line of higher gradient means faster but constant speed. And third point, flat horizontal line, it means object is stationary, not moving at all. Now, children, that I want to move to the next topic, and this is distance time graph, but gradients. From the distance time graph, if you are able to calculate gradient, then what you can calculate, what information you will get, what kind of information will you get from the gradient after finding the gradient of distance time graph, children? Do you know how to calculate, children, gradient? It's a mathematical term, children. I hope that in mathematics you have learned about the gradient. So let me draw this horizontal line, children, and this is distance versus time. And just let me take this is some angle theta. Gradient of this graph. Gradient of a graph is given by rise over run. So if I take 2 points in this graph, the first point is at the origin point and another point at the last point, suppose, and just a little bit construction here, and I will form a triangle. I will get a triangle. In this triangle, I need to calculate gradient, which is given by rise over run. So rise over run means the y-axis. In the y-axis, what I have? I have distance. I have distance. Distance between any 2 points. Run means along the horizontal direction, I have time. I have time. So gradient, from the gradient, children, distance divided by time. Jasmine, what is distance divided by time?
Sorry, sir.
What is distance divided by time?
Rise over run.
Yeah, distance divided by time here from the graphic is rise over run. But may I know what physical quantity we get when we divide distance by time?
Speed.
Yeah, we get speed, children. So it means gradient. After finding the gradient of a distance time graph, children, you can calculate speed. That in the beginning of this lesson, children, I told you that from the graphs, we can predict, we can find some different kind of values. First, suppose I started this topic from a racing event. You are running a car. You are driving a car, children. You are participating in running a racing event. So finally, any observer want to find out your speed, with what speed you have moved in that competition. You can calculate, the observer can calculate your speed by just plotting a graph and by finding the gradient. So gradient is given by distance divided by time, children. We will discuss more about the gradient, but let me move ahead first. So you can find gradient is given by change in position divided by time, actually. So one example here, calculate the speed of the bus in section C. Children, please calculate the speed of the bus in section C. Let me go to the section C and find out, children. Find out section C, just focus on section C, remove A, B, and D, find speed. Already we discussed, I already calculated this value, but students, you try by yourself now. In from graph C, find speed, and I told you children to calculate speed, you need to calculate gradient in the time interval of 400 to 600 seconds. May I know the answer, children? Gradient. You can type your answer in chat box, children, and let me do also gradient in section C. We are doing rise over run. So here you can complete this triangle. What is rise? What is this value, children? Listen carefully. If some of you are not aware how to find the rise here, this rise will be highest value 400. Sorry, not 400, 1400 minus the lowest value starting from this point. The difference of 1400 minus 400 will give you y component here. So the value of distance divided by time taken. Time is again in this line. How much is this time? 600 minus, this is run, 600 minus 400. Every time we have to do, children, in this way. 1400 minus 400 will be 1000. 1000 meter divided by time. 600 minus 400, this is 200 in seconds. 2 zeros, and you will get 5 meter per second is the answer for this question. I received one answer from Chavila that she said that 5 meter per second. Other students, did you get the same answer?
Yes, sir.
Ayush, okay, good. Now let me move ahead, children. After finding the speed of this graph, after understanding the meaning of gradient, let's move to the. Now, children, I want to tell you one more thing from this graph. In exam, two kinds of questions can come. Only just two categories are there. First, in exams you will get a graph. Graph is there, and from the graph you have to interpret the graph. You have to interpret the graph means what kind of motion is this, like graph number A. Is this speed is increasing or decreasing, or whether the object is moving with the constant speed. Similarly, for the graph, what type of graph is this? Means you have to interpret the graph. Second kind of question is that data is given, information is given, and you have to plot a graph. Are you listening, 9th class students?
Yes, sir.
Yes. So second kind of questions is informations are given and you have to plot a graph. You have to plot a graph. So you have to understand how to plot a graph also. So let me move to the next portion of this graph, and then you can practice this question by yourself, children. And then second category of graph is, children, speed time graph. Speed versus time graph. Now, what is speed time graph again, children? A graph between speed versus time. When you plot a graph between speed and time, that graph is called the speed and time graph. Means you are taking independent quantity, time, along the x-axis, and dependent quantity, speed, which is depending on time, you are going to take it on along the y-axis. Let me show you the graph. This graph, children. So we have, it's not necessarily that you will find every time you will get the same kind of graph, children. That graph will be different, but it's an example to make you aware how to interpret speed and time graph. Observe carefully again, children. We have section A of the graph, line B, line C, line D, and line E, and we have to discuss all these points. What is the meaning of line A, B, C, D, and E? Let's begin. Now, children, remember, this time we have speed along the y-axis. Just forgot about the distance now, children. We have speed. And for a time interval of 0 to 10 seconds, observe, children, 0 to 10 seconds means initially 10 seconds, is there any increase in speed, children? Line is flat, Along the time axis, speed is 0. Can you find that the speed is 0 here, children? Speed is 0. It means if speed is 0. What do you mean by that? Object is stationary. Speed is 0. Object is not changing position. And here, from the time interval of 0 to 10 seconds, object is not moving. The object speed is 0. Here, I will take object is at rest and means motion has not started for the time interval of 0 to 10 seconds because speed is 0. What about the next 10 seconds, children? From time interval of 10 to 20. 10 to 20 seconds. Now, after 10 seconds, you can see object has started its motion, and how the motion is starting here, its speed is increasing. Speeding is increasing. You know, remember children that its speed along the y-axis is speeding up here actually. 1, 2, 3, and finally at the end of 10 seconds, children, object gains a speed of 4. Object has gained a speed of 4 meters per second. Now, children, be attentive here. Can you find out the speed is 4 meters per second at the end of 20 seconds? I don't want to discuss here initially that the mathematical part, but let me go down here, children, and tell you a flat horizontal line, 0 speed, that is stationary. That this point I discussed with the children. What about the second line? A flat horizontal line. Okay, now point number 3. Come to the point number 3, children. We are here. An upward sloping line. It means accelerating. It's accelerating, children. Now, in speed time graph, children, whenever you find upward slope is there in section B. Here it is upward slope. So what kind of motion is this, children? Can you tell me, children, that is the speed of the object constant or same? Is the object is moving with a constant speed from the time interval of 10 to 20 seconds? No. You can consider, suppose children, at that instant of time, suppose this is at 11 seconds, object speed is 1 meter per second. After 12, I'm just taking an example, it is moving with a 2 meter per second. So speed is changing, 1, then 2 meter per second, then 3 meter per second, 4 meter per second, 5 meter per second, in this way, speeding up. So what do you mean by it? Means object has changing its velocity or speed is changing. It means acceleration is there. And acceleration, you know how to calculate acceleration? Change in speed or velocity. Object move in a straight line, you know that children's speed and velocity both are same, distance and displacement are same, divided by time. So finally, children, from the distance time graph, the thing which you have to remember, if line is sloping up, it represents accelerating motion. Now let me draw here. This is speed, children. This is time here, and you find line is like this. So this graph shows accelerating motions. And now you can also conclude here whether it is accelerating motions. What kind of acceleration? The object is moving with a static acceleration. The object is moving with a constant acceleration and steady acceleration. Also, you can also predict if line is, line is horizontal. It's a straight line. Let me move to the next point, children. There is another graph number C. And what do you conclude from the graph number C, children? You can see here in graph C, from a time interval of 20 to 40 seconds, object speed is not changing. Means from a time interval of 20 to 40 seconds, object starts moving with a constant speed. Means now, if object's moving with a constant speed, then for the time interval of 20 to 40 second, acceleration will be 0. How I can say that the acceleration will be 0? Equation is, children, v minus u by t. At the start of the motion, at this point, initial velocity, what is that? 4. at the end of 40 seconds, what is the speed? Still it is 4. 4 minus 4 divided by time. What is the time interval? 40 minus 20, that is 20. 4 minus 4, this is my 4 children. This is 0. Acceleration is again 0 from the time interval of 20 to 40, and when the line is horizontal, parallel to the x-axis. I hope this part is also clear. So in a speed time graph, flat horizontal line gives you that speed is constant. And in a distance time graph, when we discuss this graph, in a distance time graph, children, don't be confused. The horizontal line, both graphs have different meaning. In a distance time graph, this is showing object is stationary at rest. Let me write here, at rest. And here, again, we have a horizontal line parallel to the time axis. But now this is showing speed is constant. Object is moving, but speed is constant. Please remember, children, these differences. Don't get confused in these informations. Now let me move, children. Another point. Again, there is graph D, line D, children. Speeding up or slowing down. Whatever this graph, compare with the B, children. How do you find it? More steeper, less steeper, children? Jennifer, if you compare with B, just by watching this graph, less steeper, more steeper?
More steeper.
What about other children? Steeper means, children, you can find about the angles. You can predict it by just observing this angle and this angle, children, are the same, or angle D is greater than in compare with the B. I find that it is looking less steeper. So it may be more steeper, children. It doesn't matter, but it may be steeper, it may be less steeper, more steeper, whatever. But the graph B and D is same, but there is a difference actually. There is a difference in speed that can calculate after finding the gradient. I will tell you now. What about the last line, children? Get the graph number E. In this line E, in this section of the graph E, you find now the line is the sloping is downward, and it means acceleration is there. But what the word we use means now the driver has applied a brake, and finally that the object is come to rest. Object velocity reached to 0 when the time is 80 seconds. It means now speeding down. It's slowing down. It's slowing and slowing and slowing down. So that word I can use, retardation is there. Retarding motion, retardation, or deceleration, deceleration. These are the few words. Or slowing down. Slowing. Now, children, let me move to the next point, children. From the speed time graph, now we can calculate few important things that you have to remember, children. It's a very important point. We have 2.5 minutes. I want to complete this topic here. Find distance traveled from a speed time graph. First, very important information, children. Very, very important. You can find distance traveled from the speed time graph, children. If someone give you a speed versus time graph, so my dear children, you can calculate the distance. How much distance has been traveled by a moving object? How to calculate that distance, children? How to calculate? Please listen carefully. How to calculate distance from the speed time graph, and information is here. You need to calculate area under the line. Please note down, children, in your notebook. From speed time graph, first you can calculate distance. How to calculate distance? By finding the area under the line. Area under the line, children. And I want to give you one example. First you have to remember, if you are able to calculate area under the line in a speed time graph, you will be able to calculate distance. How to calculate that distance? Is there any example I want to tell you? Yeah, suppose, children, in graph number C, can you find out the area under this line? Can you find out, children, this area? I can find out that this area is given by, you can predict that this is a rectangle. and area of rectangle is given by length cross breadth. One side I can take, this is 4 minus 0, means 4 minus 0, 4. And this side, this will be 40 minus 20. Sorry, I have to multiply. 4 into 20, and 20 into 4, this is equal to 80 meter. 24 is the 80. So this is the answer. And what is this 80 meter actually? 80 meter is the distance traveled by object. So now we have less than 1 minute, children. I want to continue this topic in next class. And the second information you can calculate from the speed time graph. What is that? I can calculate distance. And the first, that by finding the slope or gradient, I can find acceleration. Acceleration part we are going to discuss in next meeting, children.